In this session, we are going to do post-processing on a primary variable, that is a deformation in our case. So as you're already aware that this blue menu, context menu, is a floating menu. So we are right now in a solution, so it will show the options of the solution. How to add the deformation? You can go here in solution, under deformation, you can add the total deformation. So total deformation will be added. You can also check out the directional deformation in X, Y, Z direction. Total deformation is the resultant of UX, UY and UZ deformation. Right now we are only seeing the midline body of this. If you want to do a 3D visualization, you can go to the display and switch on this shell and beam thick style. So this is now a 3D visualization. Please keep in mind that this is just a visualization. We have not solved a 3D analysis. We have done a 1D analysis by midline representation only. So we'll do some post-processing on this results. So this contour bands blue shows the minimum value, which is 0, and this red shows the maximum deformation of 0.25607 mm. I will show you some of the contour adjusting. So this is called the legend. We can drag it and resize it. We can increase the number of bands. We can decrease the number of bands. Minimum number, it will be 3. We can shift the position of this band. We'll right click on this. We can make it horizontal also, but it's better to keep vertical. That looks good. You can try out these other options like max, mean, date and time, independent band by yourself. And if you want to bring it to default setting positions, just click on reset all. Now I'll click on context menu of results and we'll see some of the display options here. So these are the display options. It's right now scaled to the auto scale. We can fit it to the undeformed one, a true scale one, or a very high scale like this. So the scaling is important, which gives idea in which direction it is deforming. All engineers generally have this intuitive idea. If I am pulling it in the X direction, it should deform in the X direction. We are pulling it by the resultant force of 35,000 Newton, so it should deform in the X direction. And if it is matching with your understanding, then the analysis performed is correct. Or if it is not happening in your understandable behavior, then something is fishy here. We'll just see the edges option here, no wireframe. If we'll click on this show undeformed wireframe, it will show the undeformed or original position of model without loading. So this is the previous position and it is deformed to this stage, right? So and all the deformation are happening along X, which is also suits our understanding or imagination the bar to the actual direction. You can check out the undeformed model, as well as if you want to show the elements, you can click on this option, but in our case only one element is there, so no use to just show element option here. We'll click undeformed wireframe model to understand how deformation is happening. You can change the scale. So this is true scale, very minute deformation, right? 0.25 mm is very small deformation. And to visualization view purpose, we can scale it. This is just a scaling. Don't bother that this much it will deform. No, it's not. It's just a scaled one. There are some contour options like smooth contour, then contour bands. It's always preferred to go for contour bands. Iso lines options is not that much useful. We'll always go for contour bands option. Then there's a probing option. We can probe it. We can hover it and we can see the value, and whenever you will click, it will probe those value there. There's max mean probe. This is max. There's mean position showing. If you want to delete this all probe, just go here in a graphic annotation and right click here and say delete all. So it will delete all the probes except mean and max, that can be unticked from here. In views, there is a graph and tabular option. So this graph option will give you what is the deformation, and tabular data will give you the max, mean and average value of deformation. You can play animation from here also to just understand how it's, in which way it's happening, deformation. And it's very good start post-processing that we'll see first animation and how it's deformed and whether it's matching with our idea of shape change or not. That's verified. You can stop from here. These are the frame rate which you can adjust slow and fast. 5 frame is fast, 100 frame is very slow. And you can also save in video format or for this 4 format, AVI, WMV and MP4, so that you can show to your college professor how it's deforming. You can put in your presentation, so that will look good. We'll see also another way to do a probe deformation using the probe option here. We'll click on a probe and we'll say deformation probing. So deformation probe, I will select vertex. I will click on this vertex and I will say apply. In probe you have only option of result selection of particular direction. So as we are pulling in a X direction, we'll keep X direction here and we'll say evaluate the results. So now it shows the deformation probe here and the value of deformation is 0.058 mm. Similar way, let's see at this node also. So I will right click on deformation probe and I will say duplicate without result, and then instead of geometry this vertex, I will go to the vertex selection and click on this vertex. We'll say apply. Right click and evaluate the results. So they're showing the deformation of 0.19236 mm here. So this way you can probe the results. We have seen how to add the total deformation and deformation probes in this session, and next session we'll see how to evaluate the stresses and the axial forces.